morning, good afternoon, and good evening from wherever you guys are joining us from. Thank you for being a part of TestMu conference. It's the 5th edition of TestMu. Welcome to day one, everyone. I'm Kavita Joshi, Senior Marketing Specialist at TestMu AI, and I will be your host for this session on building deterministic infrastructure for non-deterministic AI agents. LLMs are probabilistic. Production infrastructure can't be. It has to work the same way every single time. So this session looks at how you turn unpredictable model behavior into workflows you can depend on. Whether you are already running AI agents in production or just getting started, there's plenty to take away from here. Our speaker today is Nishant Gupta, staff software engineer and tech lead at Meta, and he builds the AI infrastructure and distributed systems behind agentic AI platforms. He has previously led infrastructure work managing elastic compute across millions of servers, published peer-reviewed research in distributed systems and AI. And he's a well-known speaker at leading engineering and AI conferences worldwide. So guys, before we start, there's just a few housekeeping items. This session will be recorded, so you can catch it later if you need to drop off midway. Drop your questions in the Q&A box anytime. We'll take them towards the end of the session. And you can post your takeaways on LinkedIn or X. Tag us and use hashtag TestMuCon. You could win prizes up to $15,000. With that, please join me in welcoming Nishant Gupta. Thank you for joining us, Nishant. The stage is yours.
Hello everyone, my name is Nishant Gupta. I'm a software engineering tech lead at Meta working on building state-of-the-art training and inference infrastructure. Today, we are going to be talking about engineering patterns that can turn unpredictable model behavior into reliable production workflows. And the way I would like to frame this talk is as a practical engineering playbook rather than just an AI talk. Hopefully, by the end of this talk, the audiences should leave with a blueprint for how to allow non-deterministic components to operate safe inside deterministic production systems and a blueprint. So, for today's agenda, we will start first with failure modes because every production architecture should be driven by the incidents it must survive. We will then talk about deterministic workflow shells around the agent, specifically orchestration, followed by a focus on tools and how to manage state and what contracts we should build, followed by human and policy gates and decisions, and lastly, a production blueprint. And the thesis for today's talk is deliberately provocative. What we want to do is we want to come up with the message we're trying to deliver is that we should not wait for the model to become perfectly deterministic. We should design the surrounding infrastructure as if the model will be probabilistic, occasionally wrong, and sometimes overconfident. So why does this matter now? So in the old world, around 2-3 years back, models used to return mostly text output. A human used to copy and make decisions, and any failures were mostly visible before any action used to update the state or affect the outcome. But in this new agentic world, we are observing a shift. The model is no longer only producing content, it's a decision making component connected to real tools. Model is able to select tools, the runtime is able to execute actions, and failures, if the model decision is wrong or other failures, can mutate infra, change the data, move money, or even affect customer state, critical customer state. So basically, we want to put determinism around this non-deterministic model. And we are not trying to make the model itself deterministic because even with temperature control, structural outputs, the model is still a probabilistic planner. The engineering goal here is to place it inside a deterministic execution envelope. When the system works, we can answer, engineers can answer, what did the agent believe when it was executing? What action did it request? What schema did it satisfy? What policy allowed it to make a decision? What tools did it have access to and executed? What state was changed? And how to replay that workflow or roll back that workflow. And one of the production rules I like to follow is that every agent action should be reconstructible as a typed request. along with the politicization to result in a durable state transition. So let's talk about some of the failure modes and how agents can break. So these failure modes like wrong action, retry storm, cost spiral, silent success, these are familiar ingredients, but the composition itself is new. We all know software systems have retries, they have state machines, permissions, but agent adds an ambiguous planning and self-directed tool selection on top. For example, a deployed agent sees a failed rollout. A human might stop and ask for more context. Why did the rollout fail? An autonomous agent, on the other hand, may retry, widen the rollback, run extra diagnostic queries, and trigger another service outage. If the retries are unbounded and the permissions are broad, an ambiguous failure can become a cascading incident for the organization. So I think we have all been thinking about where does this non-determinism enter from? And as we can see on this slide, it can enter from various stages. Determinism is not only about random seeds. In agentic systems, non-determinism enters through prompt context, through external calls, tool calls, concurrent execution, state compaction when the context window is about to finish, and human feedback. This can be described mostly as an orchestrator loop. The model output leads to tool execution, tool output leads to feeds back into the model, and the loop continues. And that loop is powerful, but every step is another piece where uncertainty can amplify. A useful exercise is to ask at each layer, what is the deterministic contract? For prompts, it might be task specs. For tools, it might be JSON schema and permission scope. For state, append only event logs and identity keys. For humans, it's approval records and escalation policy. And if you're able to ask these questions, we're able to reduce non-determinism to a very, very low extent. So this is the core architectural pattern on how to put deterministic shell around that agent. The model, the key idea the model proposes and the infrastructure disposes. The model transforms a natural language intent into a candidate plan, but the runtime must own the semantics of validation, of execution, retries, and recording. This is analogous to distributed systems. We do not trust a client to directly mutate databases. We put APIs, authorization layer, idempotency, transactions, and logs for auditing. Agent deserves the same discipline. We have to put extra controls because the caller is probabilistic. To summarize, the model responsibilities are still the propose, explain, and adapt, while infrastructure responsibilities are to constrain the output, execute, verify, persist, and escalate if required to a human. So let's discuss about some of the patterns here. So the first pattern is we prefer workflows before open-ended autonomy. So autonomy is the way I view it is it's a reliability budget. We have to spend only where it creates value. Most enterprise workflows do not create agent to fully decide every next step. They need a deterministic workflow with occasional model calls for classification, for synthesis, ranking, or planning proposals, as you can see here. So agent should be a knob, not the default architecture. Autonomy via agent workflow should be a knob, not a default architecture. Pattern 2. Every tool is a contract, not a function call. So more or less when we before we execute something, right? I think what we try to do is we have a JSON schema. We try to constrain function call output to a matched schema. Or we have required fields, we do semantic validators, we preview dry runs with the tempotency keys. But the most important thing is we have to make sure that the rate, the spend limits, the side effect classification, the rollback compensation path, these are well defined. Model outputs can be constrained to match a supplied JSON schema, and we have to use that as a contract boundary, not only as a safety layer. Pattern 3, make retries deterministic and boring. So this is about operationalizing reliability. In distributed systems, retries are simple until they are not. Agent makes it much harder because the models may interpret a failed tool result and generate a new plan that looks like a retry, but it is semantically very different. So all retries should go through an orchestrator. The model can request a retry or propose a fallback, but the runtime makes the final decision. The runtime knows the retry budget, whether the call is idempotent, whether the failure is retryable, whether the budget is exhausted, and whether a human needs to approve the next step. Pattern 4 is about human approval gates being part of the overall architecture. So depending upon the action, for example, if it's a reading, summarizing, classification, it can be auto-approved. But if it's related to security, financial, legal, regulated, then mostly a human, mostly 2% humans should be approving it based on some policy. So a human gate should not just show agent wants to proceed, it should show the plan, the changes from the current production, evidence to justify the change, policy checks if the organization is defined, which every organization should, the expected side effects, the rollback paths, the confidence. Otherwise, approval is just a rubber stamping and it doesn't lead to value. This is more like a product design issue. We have to put humans where judgment and accountability matters. We do not need to make them prove every trivial step because that destroys the value of automation and causes more operational toil. We can use it as tiers. We can start conservative, measure false positives and friction, then then graduate actions towards automation only with enough evidence. Pattern 5 is about zero trust action model. So zero trust for agents means that the model's intentions is never sufficient authorization. The runtime evaluates action requests against the user identity, the tenant boundaries, tool risk level, data classification, change window, rate limits, and policy. Basically, the way the mental model here is policy as a code. The model produces an action request, the action validator builds a policy input document, and the policy engine returns should it allow that action, denied, does it require approval or does it require more context? And the agent cannot bypass this because it never receives raw credentials, authorization, or authentication to directly mediate production. This helps us preserve the integrity of this whole workflow. Pattern 6 are about evals becoming release gates. So evaluation for agents must include the environment. A chatbot eval, for example, can ask, was the answer good? But the agent eval should ask, did the system choose the right tool? The right permissions, respective permissions, stop when it was blocked, recover from partial failures, ask for human approval if required, and remain within the cost and latency budget. And these are very important things as we can see here because no agent should ship unless it passes the normal software test plus adversarial tool use scenarios and the rollback escalation drills we have already conducted. Pattern 7 is about observability for decisions, not just for services. So traditional observability tells us about latency, error, saturation, logs. Agent observability needs all of that, plus semantic traces. We need to know what the agent saw, how it interpreted the task, what plan it created, what tools it chose, what policies it ran, and what it believed the outcome was. A good incident console dashboard should answer, did the failure originate in prompt context or model reasoning or tool behavior, policy denial, human delay, or external service failures. Without this, the teams will blame the model for infrastructure problems and blame infrastructure for model problems, which is never a good thing. So when designing dashboards, the main question we have to ask is dashboard should be able to answer is why did the agent do that? A particular action. Pattern 8. It's about budgeting every workflow like a production resource. So the way I view this is we have to view cost also as a safety signal. The agent that loops, fans out, or keeps expanding context is not merely expensive. It might be confused, stuck, or acting outside the intended workflow. So we have to include practical controls like token budgets, like step budgets, max steps, how many steps it can take, what is the maximum work clock time, number of tokens, fan out it can do, or retries, or maximum amount of dollars. And when the budgets are exhausted, the right behavior is not to keep reasoning. It is stop, summarize the current state, and escalate it with a clear next action plan a human can review so that we can iterate and optimize the workflow. So this is a rough reference architecture around a deterministic agent runtime. So going from left to right, the user intent, for example, enters a normalized task envelope. The planner proposes bounded steps. The validator checks the schema, the tool availability, and semantic constraints. The policy engine decides whether to allow or deny a request more context or require approval. The tool broker then mints scoped credentials to that agent and that action and executes in a sandbox so it doesn't affect the production whenever possible. And if each and every step is written to an append-only trace and state store. So the key security property here is that model never directly holds broad production credentials. The key reliability property here is orchestration, state, retry, and verification are owned by deterministic services. And the key operational property here is that every agent is replayable enough for debugging and auditing purposes. So let's walk through a incident, uh, an example incident on how deployment remediation agent can work here. So the unsafe system gives the agent, for example, unsafe path before if we don't put determinism, broad credentials, and treats each model response as a command. The deterministic system, on the other hand, which we just talked about, treats each model response as a proposal. The validator, policy engine, approval gate, idempotent executor, and verifier each reduces their blast radius. It is important that the model may be identical in both the paths, but the production outcome changes because the execution fabric changes. And this is the argument for the infrastructure first agent safety. So let's talk about a rough rollout maturity model, which I have been using it in the last couple of months. So the safest path has always been progressive autonomy. We should start with suggestions, more than move to drafts where agents preparing artifacts or commands. Then tightly, then do dry runs, then approval gated productions, then tightly bounded autonomic execution. We should not jump from chatbot to autonomous production operator because each promotion from these stages should have an objective criteria, a pass eval rate, observed incident rate, approval rate, rollback success, budgeting stability, and audit completeness. In other words, autonomy should not be a product launch switch, it's an operational maturity level. So to summarize kind of the checklist basically, what we should ask when we are designing this, we should ask some of these questions. For example, are retries centralized, bounded, and idempotent? Can we replay a trace from intent to a policy decision to a tool result? Because a safe agent platform is not just a better prompt, it is a runtime, policy layer, workflow engine, and an operating model. So let's summarize some of the key takeaways. Um, the future of the agent is not model only, it's systems engineering. People who make the agents useful in production will be the people who know how to design deterministic interfaces around non-deterministic reasoning. For example, right, we have the things we just talked about, right? We have to make sure that autonomy gradually evolves with evals, canaries, approvals, and rollbacks. And the major key takeaway is that agents should be allowed to be creative in planning, but never be creative in production control. Thank you, everyone.
Thank you, Nishant. That was an amazing session. That reminded that determinism has to live in the infrastructure, not the model. In a lot of teams, that needs to be heard. Thank you, everyone, for being a part of this session. All of your questions will be answered on our community channels. So stay tuned. See you in the next session. Thank you, everyone. Bye bye.